Then for our final presentation, I actually tried to get Professor Marcus Jacobson from California to be here to do a presentation. He told me that he was unavailable. He is doing a presentation somewhere else in the world. So I thought, yeah, well, it was worth a shot. And a little bit later, he emailed me again and said that he was interested in doing a presentation another way, because a colleague of him, which is Stajano, could eventually present on a paper and product from Marcus Jacobson and his colleague named Passwords. And well, I had a look at it, and yes, I thought it was really interesting, because how many of you find it annoying trying to type in a long password on your smartphone with a touch screen? Yeah, and that's basically what, well, a little bit on what this is about. And Frank.
Thank you very much. So my contribution to this is nothing more than just presenting the work of Marcus and Rod, who used to be a student of Rod and is now a faculty in Thailand. And this is work that tries to improve the situation, as Per said, for users of smartphones who have to enter passwords. So the purpose of this invention is to give a better experience, both in terms of usability and in terms of security, and also in terms of how memorable the credential is compared to the password. So this is a survey that the two authors performed among users of cell phones. And they said, what are the things that you most hate about having to work with a cell phone? And this is a scale of pain, and the further you go to the right, and the more people hate it, because it's red, it's bad. Okay? So they don't like the poor voice quality, and they don't like the fact that sometimes the phone doesn't get enough feed to make a call. They don't like the small screen size, the difficulty of customizing the settings, and then the difficulty of authenticating through the cell phone is there, and the speed of web connection and the short battery life. You should notice how the difficulty of authenticating is even more painful than the poor voice quality, which is the primary function of the phone. So I'd say, well, this is an indication that consumers really hate having to enter passwords on handsets. So this says it all. Okay, people hate passwords, especially on the handsets. And what's wrong with passwords is several things. First of all, it's slow to enter a password on a handset as opposed to a regular keyboard. And then once you have entered something here, you might realize that it was mistyped and you have to delete and re-enter it again. And it's difficult to remember a complicated password, and the more complicated password is, also the more difficult it is to enter on a constrained keypad. And when a difficult to remember password is forgotten, then it's a nuisance to go through the reset procedure, where you have to go and maybe give answers to other things and so on. And it's also expensive for the people handling the backend to have to field those customer calls for performing the reset. It's also insecure insofar as you are being asked other questions, which may be easier for someone to social engineer the answer to than guessing your password. So instead of using passwords as such, you may use pins, just numeric passwords, only digits, which are faster to enter, certainly on a handset, but they are not very secure. And it's very common that people would use the same pin for many things. And apparently one thing that they say is that 1 out of 5 people choose their spouse's birthday as a pin. And there's only 365 possible birthdays. Yes?
The real reason for that is that it makes it easier to remember your spouse's birthday.
That's a good one.
Which would be more disastrous if you forgot.
Yeah, I guess the reset procedure in that case is very expensive. So, the question that they set to themselves, understanding the usability problem with passwords, is why is it that passwords are more painful to enter than text? Because when you enter regular text, you have the help of a big dictionary on the phone that corrects all the spelling mistakes you do. Whereas with passwords, of course, the opposite is true. And a good password is like not a dictionary word, so it's bound not to be something that you can correct. And so the core idea they have is to try and think about this and reverse this contradiction to get a new insight and a new way of doing things. This is some amazingly old psychology research. It says the things that are easy to remember, the things that are memorable, are things that are somehow meaningful to us. And a good password, in quotes, is something that is totally meaningless, a jumbled characters picked up at random. So that's why it's difficult to recall them. So in that sense, it would be much easier to recall something that has some meaning for us. So I apologize, on my Linux computer, the file that he sent me wouldn't work at all, so I had to convert it to a static PDF. So we are losing some kind of animation that I guess must have been there. And what happened here is that the user would type a word, and the word would be auto-corrected to the correctly spelled frog instead of froth. You write froth, and it's auto-corrected to frog, and then it's easier to enter frog, but that's not so good as your password because there aren't that many possible words, so it's easy to just try them all. So because this is not secure enough, just hold on and we'll see how to do this better. So user is entering a dictionary word, and then after that he's just entering another dictionary word, and then another dictionary word. And each one of these words can be auto-corrected with a dictionary that's already in the phone. So if you add enough words, then you can improve the security up to a level you are comfortable with. And so this is what the authors call a fast word. Fast word is actually a set of several words, which is fast because it's fast to type because you are helped with the normal autocorrect that you use when you run normal text, and it is some kind of password. So this other slide shows the speed it takes to enter various types of credentials on various types of devices. So we have the strong passwords. I asked if they had any specific meaning to strong passwords. They said, well, it's something that you consider good enough to protect your online banking with. What you use on financial sites, things that have money attached to it. And then a weak password is what they characterize as something that you use for some less important account. You're not going to lose much if you use this correctly. And so a weak password is going to be easier to enter, presumably. And you check what happens on a mobile device, on a desktop computer, with a strong weak password, and a fast word. I'm not sure that the arrangement makes too much sense, but all the cases are there. So on the x-axis, you have the speed of entering the credential in seconds per character. So the better thing would be to use fewer seconds per character. So to be on that side, this is better and this is worse. This is fast and this is slow. And you can see how things that are typed on a desktop are faster than things that are typed somewhere else. However, when you look at the fast word, then you get things that are comparable to what happens on the desktop here. And this is at first quite surprising, but what you have here is that you are helped by the autocorrection. So you can type quickly, even slightly carelessly, and then you're helped by being sent back by the dictionary in the phone to the correct words. In if you did try to enter a strong password on mobile, then you would have a much worse situation to try with this. So the password would be, oh sorry, question.
Well, I was actually looking at the speed, and if I'm thinking about 1 character a second on the keyboard, for example, then I'm thinking that the users are slow typers.
Yeah, that's probably true for most users.
Most users are. Plain and simple.
Yeah.
So maybe change that instead?
Well, no, because I was trying to look at it, and it seemed the gaps between the cell phone and the desktop, of course, expected to be longer, and I guess.
Yeah, well, I mean, most users are not Dutch typists. I mean, we are not talking about the top users or you or whatever. We are talking about users who have trouble entering their passwords, and they would probably hunt and peck with just the fingers.
If this is speed per character, then wouldn't the fast words be longer to type, take longer amount of time?
Yes, yes. So the fast words would be longer to type, but they would be more comfortable to type, and you would take less for each character, and it would be easy to type the whole thing, but you'd have to do more characters. An interesting point about this is that the number of characters that you enter is not exactly representative of the effort you have to put in to type it in, especially on a handset. Sometimes you have a character, you have one of these strong passwords which are made of upper and lowercase and symbols, and just to get to the upper and lowercase you have to press so many other bullshit things to shift and this and change the character set and so on, that you end up, maybe if the character is 8, if the password is 8 characters, you end up having to type in maybe 20 keystrokes to get to those 8 characters. Even without counting the fact that I have an old V3 smartphone, so I have to type more just to get a single character. Even on one that has this type of soft keypad, you cannot type the numbers and the lowercase letters unless you switch and flip back to various versions of the keyboard. So you'd have to do a number of key presses that is not reflected accurately in just the length of the password as a string in terms of that. So, their claim is that it's about 2 to 3 times faster to type the whole credential with a fast word than it is to do it on a regular keyboard. This is a look at the security of this system, where this graph, scratching head, this graph is a cumulative distribution for the security of the passwords from a usability experiment that they did, where the usability experiment consisted of seeing what passwords the users would set and then comparing it with, I guess it's NIST provided statistics about the security of the average password. So this is the paper that you should refer to if you want to get to.
Is it being listed as the 800 maybe on entropy and password strength?
It might well be.
Could be, yeah.
Yeah. Okay, well, I'll find it later if we want to have the exact reference. But anyway, this is computed from their experiment. This is looked up in this NIST document. How the probability of guessing the password would be 2 to the minus 20, 2 to the minus 25, to the minus 30, and so on. There are that many passwords that can be guessed with that probability in total. And so the further this way you are, and the higher the probability is that you can guess passwords over there. Yes?
How many words do you expect to be in this password?
I think this is a configurable parameter. In the example so far they have 3, but it's something that you could tune.
Okay.
So there's more numbers in the paper about how you would choose how many words to have and what else to do based on what probability you want to have. And you see there's quite a huge gap here between the probability of guessing a password, a normal password as chosen, and one that is according to the password rules. So let's say this is make up 3 words. But they decide we can use this gap, we can close this gap and spend some of this budget on improving the usability. I mean, this is the next slide or the one that comes after that. So if your password is slightly hard to remember and you are prompted to enter the password and you don't know what it is, then they claim we can give you a hint to your password by giving you the first of your words. And the way they suggest you could make up your password is by, for example, making up a story and selecting words from your story. So this is stuff from this experiment attempt. There's about half a dozen examples. One guy says, my mother had a stroke 1 week before my wedding. Okay, so from this sentence, which is a memorable thing for this person, they select the words mother, the words stroke, and the words wedding. As they select these words, and they, at the time of creating the credential, they submit these as their password, then there's a computation made of the relative probability of these words. And they say, okay, my mother, the word mother is 2 to the minus 13.8. Stroke is 2 to the minus 15.7. And wedding is 2 to the minus 13.7. Now they also check the aggregate probability of having these 3 words together based on an n-gram statistical distribution, which is, there's apparently a service provided by Microsoft that says how likely it is that these 3 words appear together. And they reject, at the time of enrollment of the credential, any passwords for which these probabilities are too easy to guess. And only the ones that are seen as sufficiently unlikely are accepted as valid passwords. Now, another one says, okay, I left my house one day to find my bicycle had been stolen. Later I saw it outside the convenience store, so I waited there for the thief. That's how I met my wife. So the guy makes this little story and remembers the words bicycle, stolen, and wife. And this is their password. So the claim here is that it's going to be much easier to remember the 3 words that are associated to the story that you made up once it's been accepted as valid ones, than just remembering random stuff. Now, you may remember these words, but only after a hint. So maybe in this case they say, you forgot your password. Well, it started with bicycle. Oh yeah, it was bicycle, stolen, and wife. And another thing you might do is you might remember them, but you might remember wife, bicycle, stolen. You might remember the same words, but in the wrong order. And another thing, you might remember bike, stolen, wife. And they might maybe like slight synonyms, or maybe homophones for some of the words. And if you, I mean, there isn't that much detail in the slides that Marcus sent me, but if you look in the paper, there's fascinating stories about how essentially they use this gap in the how much harder the passwords are to guess. They spend much of this extra security margin budget to make the system more usable in, for example, allowing the hint to be given, and still what remains is more secure than the average password. And then another way is making it indifferent which order you give the words of the password. And so, of course, this reduces the number of, I mean, many passwords are going to be valid for just one thing. This pushes this line further to the left, but that's still to the right compared to the green one. And also including homophone classes, so that if you write bike instead of bicycle, it's still accepted and so on. You're still pushing this line to the left, but you're still doing better than passwords. And so, and if you wanted to add more security margin, you would add a further word, of course.
I think this is, I'm actually remembering back at PasswordsCon in December and Kirsi Helkala, because she also did some, in her talk, she was also talking about remembering 3 simple words and the recall rates for those. It's like, it's kind of a pity because we're not allowed to put out the video recording of that presentation on the internet, at least not in December. so I can ask her again, but she has also been looking into just using 3 simple words and then examining recall rates for that among students and
So
others.
this is a strategy that has been used. I mean, it's the strategy in itself of using several dictionary words is not novel as of itself. I mean, even they cite America Online used to give out those discs for signing up people, and there were user ID and password where the password was made up to dictionary words joined by dash. You may have received many of these as junk mail. I mean, I remember receiving them. And so, so long as you have let's call it an alphabet of words, I mean, in this case, 64K words, you're just making a word, a super word with this mega alphabet. And you just, as you can make your password longer, you can make your password longer if you need more security margin. So this table here is not about the security, but is about how memorable the password is, because one of the problems is that you make a complex password and then you forget. And so here, recall rates for the various credential types: a single password, simple password, or a strong password, one that's mixed case and meaningless and with all the various classes, characters, super strong passwords, pins of various lengths, and then the password. And then here you also have another line for additional after a reminder. I'm not too sure what the reminder was for the strong password, but for the password, maybe it was something that you register when you enter the password. Say, what's your password reminder? And then you enter something that it's debatable how much this gives a hint to a cracker as to what the password might be. But in this case, the hint was definitely the first word of the password. And here they asked users, what do you think your recall rate is going to be for this? And this is what the users estimated. And this is what they measured with an experiment. And they found that users thought that they would recall this at this rate, 24%. And in fact, they only recalled it at 14% and so on. And you can see consistently, this is, they remembered it much less than they thought they would. And in this case, if they had forgotten the password after the reminder, they still not clue. However, with the password, surprisingly, the users estimated something lower than what they actually obtained. And if you accumulate what they got, the password as primary recall, and then after the hint, this added together like that gives a 67% recall rate, including the hint. So, yes?
I just wanted to make a quick comment that I had a little bit of psychology training, and that's one of the things they test for in memory. The psychologist gives you 3 random words and tests you 5 minutes later or 30 minutes later and tries to see if you can recall them. And if you can't, then they give you a category. Like, let's say the words were blue, Chevrolet, Houston, and then they'll tell you, well, one was a color.
Right. That might be the hint. So, although notice that in the case here, we were not talking about password with 3 things with a category. So the strong password was not necessarily a dictionary word. So it may not have been exactly that type of hint, because they couldn't say it was a color, because the strong password is supposed to be more than just the color switch, less than 100. So I was saying earlier is that as you give the hint, then you're moving this line towards the left, but you're still doing better than the average password. And there's okay, so they say that there's 2 ways in which giving you the first word reduces the security. One is that, of course, you're giving out part of the credential, but the other one is that it could be that the words are related in some way that someone else could use for enhancing the guess. But still, that's better than the other one. The other thing they point out is that it's difficult to tell for sure how secure a regular password is. This is, they get this estimate, but they can't really do proper computation. Whereas with the fast word, they use this frequency distribution of the individual words and frequency distribution of the n-grams, and they can have a more accurate quantitative measure of how likely it is to guess that particular fast word. So finally, this is the take-home message about this invention is that the way that they managed to improve the authentication in the dimensions of more security, more usability, easier to type, and more convenience, easier to remember the password, is to start by understanding what was wrong with the passwords as they are and see if some other solution could work better. So they have a website, they're offering this as a commercial product, password.me, and they have also this paper which is being submitted to the ACM CCS, and the draft is available, and you are welcome to write to them at the address that you find on this website if you want any further details. But for the moment, if I can, I'll take any questions. Yes.
Well, the first thing comes to mind is that, well, have you seen a web page called Damn You Was Correct?
I haven't seen it. I sort of guess what it might contain. Yes.
So the way these dictionaries work, if they're using the local dictionary, is that they kind of tend to learn which words you use the most, and then when you type, they present you with a completely different word. So if you use one word too much, that might, well, if it works as it's supposed to be, that might actually replace the word that you originally used for your password. Alternatively, it will suggest something ridiculous, which is the basis of that web page. Also, if it's...
Well, one related point that they make in their paper is that they insist that when you choose a fast word, the individual words of the combination must be words already in the dictionary. Because if you chose a word that's not in the dictionary, you'd have to add it to the dictionary, then it would be stored on your handset as something that you entered, and it would obviously be
Exactly, and there's another problem. If someone knows that you're using fast words, and you're a dictionary of what, 64,000 words, that's only 64,000 to the power of, what, 3, 4? Not that many combinations.
Well, it's
Yeah, I was gonna say,
it's still better than the green line, too. The 64 is better.
Is it really?
I was gonna say, open up BC or something and do the math. My calculator or my calculator on my phone decided not to do more than 64,000 per second. Oh, it takes 64,000 to like the second, and then take like log base 2, or 64,000 to the third, or log base 2. I don't know what the actual numbers are.
64,000 is to the 16th, right?
Approximately, yes.
Yeah. So multiply that by 3, that's a 2 to 48. That is better than 2 to the integer, whatever it is.
Yeah, even with 2, you get just 2 to the 37.
But I mean, both the paper and the product have two purposes: increase usability, while at the same time actually also increasing security, right?
Yeah.
Yeah. So you can enter longer passwords in the same amount of time or even lesser amount of time than earlier.
Well, this is a product that is designed for compatibility and deployment, easy deployment now. So you don't have to change the handsets. What you do is, at the back end, you insert a facility for accepting the fast words. And then the authentication thing asks you to enter the password. First of all, when you enter the credential, I noted that you have a question. When you enter the credential, it will check if it's valid. And that's the place where you can set the policy. I want my passwords to be 3 words long, or 4 words long, or 6 words long. And I'm going to allow homophones, or I'm not going to allow homophones. And I'm going to allow synonyms, I'm not going to allow synonyms. I'm going to allow permutations of the order. Of course, these are trade-offs. You want to make it more usable, then you can remember white, bicycle, and stolen in any order. But then maybe you have to add another word to compensate for the fact that you're giving this extra convenience in remembering them in any order. So in one day you're giving some convenience, or where you're taking it back by making it longer and so on. And you can tune all this, but this is the policy that's decided by the verifier. And then after that, you don't have to have a special client on the smartphone. You can just authenticate it with the password. So long as your smartphone does the dictionary correction, then you're all set.
Even if it's Steve Jobs deciding what to put or not to put into the dictionary?
Yeah, or you
It's
can-
kind of, I got the feeling that this is a product for Android phones, not for Apple iOS iPhones, but I don't know.
why would you claim that?
Well, partially because of the website that Jan was referring to. Like, I mean, it's easier to change and fix and eventually destroy everything on your Android phone compared to an iPhone. But yeah.
Now that you mention it, it might be an improvement to use the Steve Jobs dictionary. Because if you start typing just one character, it'll come up with some wild suggestion that has no relation to anything else you just typed. That would be your password.
Yeah, that's actually a good point.
Hey.
It goes to one territory.
I like this idea, but I strongly doubt that most people have an active vocabulary of 64,000 words. And if you choose your own words,
You might listen.
I mean, in general, I think 10,000, 20,000, or I don't know, Shakespeare uses, there are some numbers.
Yeah, but there are also numbers saying that in the Norwegian language,
Yes.
actually, there are a bigger spread of words in use than in English language.
We only use
Yeah, yeah, I know.
700
I mean,
words.
there are many different numbers, but still, I mean, if you're trying to look at this, if you actually want to analyze the security, if you know that people are using passwords, then, I mean, one thing is to have a big dictionary.
You are
need to
absolutely
know-
right.
yeah.
I mean, you're 100% right. But this is why, in this extended example that they have here, they first state for each word, they compute the likelihood of that specific word. And if we look at the example we had earlier, the bicycle, stolen, and wife, which is a relatively common and also short word, is also only 2 to the minus 14.3, which is not 2 to the minus 16, which would be 64 K dictionary. But if you go to some other example which says, I don't know, I always thought penguins were the size of humans. Then penguins is a slightly less likely word, and it goes to 2 to the minus 17.5. So for each word, the back end, when you try to define the credential, assesses the probability of each of the words and then of the trigram or the n-gram or whatever it is. And then it says, that's not good because you have 2 easy words. I mean, this is just going to be an easy to guess password. So it blacklists them dynamically as you choose easy ones. But if you choose complex ones, then it would let you. So that is safe enough for the policy I have set.
I have basically 2 issues with this. The first one is, if the system can tell me my first word, it has to store my password in a clear text, which from my feeling is very bad. The second issue is, when you mention the 2 sentences, as soon as you finish with the first sentence, I already knew which 3 words you were guessing or using. And on the second sentence, actually I missed the first word, but the other 2 words I guessed.
So I understood the first question, I'm going to answer it. I didn't understand the second question.
Okay. The second was, you told 2 sentences and you dragged 3 words out of it on both sentences. The stolen bicycle, the bicycle stole wife,
Yeah?
and the other one. As soon as you told us the sentence,
Mm-hmm.
in the first one, I directly guessed the 3 words correctly.
Right.
And on the second, I missed the bicycle. I thought it was house, but the second 2, I was correct.
Right, but nobody is going to tell this story to anybody. It's just
Sure.
the mnemonic that the person uses for themselves. If I just tell you wife, bicycle, and stolen, you don't have a fucking clue what the story is about. You know, my wife stole my bicycle. I mean,
You took half of the word.
You maybe already wrote the story that you met your wife after a stolen bicycle or something like this. So if this is a sentence, for example, on Facebook, you are...
right. That's the perfect. If you know something about the user and they've already told other people that they met their wife when their bicycle, blah, 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 then yes, of course, it would be a pretty poor choice of password for that user if he's already plastered it on his wall. Now, the first question you mentioned is a technically important point to make. If you give out the first word as hint, then you must have stored it in plain text, and you don't like the thing to have stored in plain text. So what they do is actually, for a given fast word, they will always give the same word as hint, and that word will be stored in plain text next to the salt and all that stuff. The other things will be hashed. So the whole fast word is not stored in plain text, but the one you have to give as hint is stored as plain text.
Which brings us to the point that you, for 3 words, just has to guess 2.
Of course, because you're giving the one as a hint, you would give the hint to the attacker as well. So that is the case anyway, that your security margin is only the remaining words. That is the case in whatever.
Carsten?
So if this is over a cell phone and backup that takes you to your server, is this like over SSL or?
Yeah, it would have to be, otherwise there would be no point because you could sniff the stuff that is being sent. Who was next? Yeah.
If I understand it correctly, if you're going to use the device dictionary, you would have to perhaps display the passwords on screen, right? Does the paper discuss that in any way?
Yeah, I guess that the thing that I was sent and I could not run on OpenOffice would show that in this animation that I have been told would work, and I have never seen. In fact, there's in the paper, there's something that says as soon as you have typed the word, you can have the JavaScript star it out. So it's completed when you're doing the word, and when you hit the space for doing the next one, it becomes stars. That's what they have in the paper. Yeah. So the next bit after this would be, this word has been entered, there's a space, you're entering the next word, it's letters here, and this is just dots in here.
But you can't type it in cinema or on the bus because somebody sitting behind you would very easily read it.
Yeah, but
The
still,
entire
but still, but still, I mean, they could be sitting behind you and see you type in your 4-digit PIN as well. So it's
consider your 4-digit PIN. Yeah, but yes, compared it to a strong password, which is a different thing.
Yeah, but still, you will be the subject of a target attack, more or less, and it really doesn't scale.
No.
If you know you're using this, you can do it the same way that you type your PIN.
Yeah.
Who was next? Are you keeping track of who was next?
No.
I don't know, it reminds me of some of the work that's done on the Diceware wordless, or Diceware system for passwords, which is, they have created a subset of, I think it is from 1 to 4 letter words that are selected because they are common and different, so that if you choose, say, 4 words and join them together, you end up with something that is more or less as random as the selection of words.
It also involves the shaking of dice in a box to make the word selection.
Yeah,
so that it's random. Then the words won't be connected to anything, which goes back to the people won't remember it.
Yeah, it's
I know, I've tried the system before, and once you're trying to do 4 or 5 words, it starts to get a little bit trickier than just straight memorizing a hard password for me.
Oh yeah, I mean, but what we recommended would be to make a reverse mnemonic. Instead of thinking of the story, picking words, you pick words and you make up the story. So that's a recommendation. But it's still interesting from the security perspective because I feel that the numbers, the entropy numbers, seem very high compared to what was based on that Diceware list, which is single digits, spaces, and short words.
Well, I guess in terms of recall, something that you have made up yourself is still always going to be much easier to remember than something that has been given to you and you had to come up with a way of linking it to something else.
So the question is, or a trade-off is between recall and the predictability
Yes.
of
Yes, especially if it's a story you've already told them.
Yeah.
Okay, well,
Right.
3 o'clock. So I'll just say thank you once again, Frank. Let's close it out. Well, that's the more or less the end of the conference.